So hello everyone. Okay, we have a problem here stating that an engineer was asked to design a singly reinforced rectangular beam. He decided to use a simply supported beam having a cross-section of 358 by 205 millimeters being exposed to the weather. He will be using 3 to 25 millimeter rebar with shear reinforcement of 12 millimeter. Determine its ultimate moment capacity. Use Fc prime equals to 21 megapascal and Fy equal to 414 megapascal. So before anything else, before we proceed to our solution, let's identify our given in this problem. So we have a given. Lagi nating sisimulan yan sa pag-identify muna ng ating mga given. So we have to identify our given in our problem. So we have a cross-section of 358 by cross-section 358 by 205 millimeter. Okay? Kapag we are talking about the cross-section, if you are talking about the cross-section, this is H and this is base. Okay? Height times base, lagi kapag cross-section. So, we have H is equal to 358 millimeter. Then we have base equal to 205 millimeter. Okay? Next, ano pa yung mga given natin? So, sabi dito, he will be using 3 to 25 millimeter rebar. So, 3 to 25 millimeter rebar, ito yung area of tension reinforcement natin. This is AS is equal to 3 to 25 millimeter. Okay? Yan yung area natin for our tension reinforcement. This is our diameter. Okay? Diameter. Wait lang. Ang pangit ng circle. Diameter. Next, ano pa? Ano pang given sa atin? With shear reinforcement, with shear reinforcement of 12 millimeter. Shear reinforcement of 12 millimeter. So, diameter yon ng shear natin. So, let's say, shear reinforcement, shear reinforcement of 12 millimeter. Let's say this is dt. In terms of dt, equal to 12 millimeter. Next, ano pa? If we have a shear reinforcement, we also have a flexural reinforcement. Okay? Flexural reinforcement, or let's say this is denote as dB. Flexural reinforcement, ito yon, yung 25 millimeter. Next, we also have a given of Fc prime and Fy. So let's write this as Fc prime 21 MPa per megapascal. Then we have Fy equal to 414 MPa. Okay. Okay, next. Isulat na natin lahat ng mga given sa problem natin. Okay. In-sketch ko na din ang ating drawing for this one. So, ang H natin dito, H is equal to 358 millimeters. Ang base natin, this is base, is equal to 205 millimeter. This is the cross-section. Cross-section ito ng supported beam natin. Then, we also have a diameter ng shear reinforcement natin. This is dt. dt is equal to 12 millimeter. And also, we have a our area of tension reinforcement, AS. This is AS. This is AS. Okay? I-label lang natin. Then, according to the problem, sabi dito, okay, having a cross-section of 358 by 205 millimeter being exposed to the weather. Being exposed to the weather. It means, sabi dito, since the beam is exposed to the weather, our concrete cover here it would be equal to 50 millimeter. Ito po yun. Ito po yan. CC. Okay, concrete cover exposed to the weather. CC is equal to 50 millimeter. Okay. So, all of our value is in terms of millimeters. Units pala. Okay? After we identify and label all the givens in our sketch, first, the second step that we're going to do is to compute the effective depth. So, effective depth. Okay? This is our solution. Okay, number 1. We have to find our D. or the effective depth. Effective depth, okay, sulat na lang natin to para magets nyo. Effective depth, okay, dito. Effective depth. You have to compute the effective depth or the D. Okay. Okay. Effective depth. So D is equal to height minus the concrete cover minus yung diameter of shear reinforcement, or let's say this is denoted as dt, minus ang ating flexure reinforcement diameter db over 2. Ayan. Yan yung pag-compute ng ating effective depth. So let's substitute the values of this variable. So we have d is equal to our height here is 358 millimeter. Okay, minus our concrete cover 50 minus our area of tension reinforcement. This is equal to 12 minus diameter ng flexure reinforcement natin. This is 25 all over 2 divided by 2. So we have to simplify this. Our effective depth here is equal to, okay, round off your answer into 1 decimal place only. So we have a 283.5 millimeters. Okay? Millimeters. We already have our effective depth. Okay. Next, after computing the effective depth, second, we have to compute or we have to find our beta 1. Okay? Find beta 1. Okay? Finding beta 1. So, ano ba ang formula kapag naghahanap tayo ng beta 1? So, may condition yan. According to our code, kapag ang FC prime mo is greater than or equal to 28, ang gagamitin nating beta 1 is, okay, sulat natin. According to code, if your FC prime is greater than or equal to 28 MPa, since our FC prime here is less than or equal to okay, ulit pala. Guys, kapag yung FC prime mo is greater than or equal to 28 megapascal, you will use beta 1 for finding beta 1. Beta 1 is equal to 0.85 minus 0.05 all over 7 times FC prime minus 28. Okay? So, this is according to our code. Next, if your FC prime is less than 28 MPa, you will use beta 1 equal to 0.85. Okay? Yan. Sabi sa code. So, upon reading our problem, stated here that our FC prime is 21 MPa. So, nagsatisfy siya dito sa pangalawang condition. Here. Our FC prime here is 21, which is less than, this is less than 28. So, we will use our beta 1 equal to 0.85. Okay? Use. Ito siya. Okay? Next, after we find or we compute our beta 1, our beta 1 here is 0.85. Next, after we find the beta 1, we have to assume that we have to find the depth of compression block or yung A. You have to find the A. Okay, wait lang. Number 3. We have to find the A. And also the location of neutral axis. neutral axis from compression. Okay? Axis from compression fiber. Or this is called as, denote as C. Okay? We have to find, after finding data 1 and the effective depth, we have to find our location of neutral axis, finding the location of neutral axis from compression fiber or C, and also we have to find the A. So we have to assume, okay, assume Fs is equal to Fy, okay? Then kapag nag-tension, assume natin na mag-yield siya. Okay? Tension yields. Okay? So our formula here is T is equal to C. Tension is equal to compression. So 0.85 ay mali pala, baliktad. For our tension, AS Fy is equal to compression. So ang compression natin dito ay 0.85 FC prime AB. Okay? That's our compression. So, substitute natin yung mga given value from our problem. So, we have area of steel. We have, may tatlo, 3 to 25 millimeter rebar. So, 3 times pi over 4. Diameter natin is 25 millimeter squared. Fy natin, 414 MPa equal to 0.85. This is our beta 1. 0.85 FC prime times 21 times yung A natin, which is unknown, times yung B natin, or yung, okay, sa cross-section diagram ang B natin dito is 205 millimeter. 205 millimeter. Okay? So, solve natin yung A. So, 3 times pi over 4 times 25 squared times 414 equal to 0.85 times 21 times A times 205. Shift solve natin. Okay? We have our A here is equal to 166.5 decimal places ang gawin natin. 6937 millimeter. Okay. May value na tayo sa A. So we have to find the location of neutral axis from the compression fiber or yung C. So ang computation natin for our C is A is equal to beta 1 C. So we have A 166.693. Nakaba natin to. We have 166.937 equal to beta 1 which is 0.85. 0.85 then C. So RC here is equal to ilan? 166.6937 is equal to 0.85 times X. Shift solve. We have 196. Malaki. 196.01102 millimeter. Okay? May A na tayo, may C na tayo. Okay? Okay na. So, tingnan natin. Next step. We already have our value of effective depth, beta 1, the A and B. So, okay. Fourth step. Ito natin lagay. Medyo mahaba yung ano natin eh. Fourth step. We have to use the strain compatibility. So, i-check natin if we use the strain compatibility. Ang purpose nito is in order for us to check if the beam is either under reinforced or over reinforced. Okay? So, kapag ang strain, okay, according to code, our strain S here, strain S is greater than strain Y, okay? Strain Y, this is reinforced. Or strain T. Let's say this is strain T. Okay? If strain S is less than strain T, this is reinforced. Our beam is under reinforced. If our strain S is greater than or equal to strain T, this is under reinforced. Okay. So, ang gagawin natin is we have to get our strain S. Okay? Strain S, finding you have to find strain S. Or let's say this is strain T. Mali pala tayo. Okay? We have to change this into, this is strain Y, and this is strain T. Strain T, strain Y. Okay? If your strain T is less than strain Y, this is reinforced. If your strain T is greater than or equal to strain Y, this is under reinforced. Under reinforced. So we have to find our strain T. Strain T. So strain T, uh, paano yung ano natin dito, strain T? Strain T is equal to 0.003 times the quantity of dt minus c, dt minus c all over c. Okay? Okay? So, we have our dt. dt is ito, yung kanina, yung area diameter ng shear reinforcement natin, denote as dt. 0.003 times our dt, 12 minus ang nakuha nating c. Wait lang. Iba pala yung ano natin dito. Our dt here is our d pala 283.5. Ano ba yung 283 natin dito? Our d, effective depth. Okay, so we have to change this. We have to change. Iba kasi yung ginamit nating variable. So this is 0.003 times the quantity of d minus c all over c. So our effective depth here is 283.5. 283.5 minus yung nakuha nating c, which is 196.01102 all over yung value ng c natin, which is 196.01102. Our strain T here is equal to 0.00134. Okay? So our strain Y naman, we have to compute our strain Y. Strain Y is equal to Fy over E. So E, ang constant ng E is 200,000. Tama ba? 200,000. So we have 414 Fy natin sa taas, 414 MPa, 414 divided by 200,000. This is constant po, yung E, equal to 0.00207. So, our strain uh, strain T is mas malaki. Strain Y mas malaki, no? Strain T is less than strain Y. So, our beam is under reinforce. Reinforce. That's our conclusion. In terms of strain compatibility, our strain T is less than strain Y. Our beam is under reinforce. So, okay. So, ibig sabihin lang yan, kapag yung beam mo is under reinforce, your A, conclusion natin dito, your Fs is not equal to Fy. Okay. So, ang ibig sabihin lang yan, your A is not equal to 166.6937 millimeter. Di siya equal doon. Tapos, ang ating C naman, yung C, your C here is not equal to 196.01102 millimeter. Okay. So, anong gagawin natin? We have to find the proper value of A and C. Diba? So, we have to find the value of A and C. Okay? Number 5. Let's add next. Find A and C. Since yung beam natin is under reinforced, okay? We have to find A and C. So, we have equation 1. Equation 1. Okay, wait lang. Fs natin is equal to 0.85 Fc prime AB. This is our equation 1. Next is yung our Fs. Fs equal to strain S times Es. Okay? This is our equation 2. Equation 3 is A is equal to beta 1 C. Equation 3. Okay? So, according to code, if your strain T, or strain T here, strain T, paano kaya to? If your strain T here, if according to code, according to code, if your strain T is less than or equal to 0.002, your phi na gagamitin dito, your phi is equal to 0.65. If your strain T naman is greater than or equal to 0.005, you're going to use phi as 0.9. So, okay. Since ang strain T na nakuha natin, ay meron pa pala. If your strain, 0.002 is less than strain T or less than 0.005, your phi here is equal to 0.65. This is according to NSCP. 0.65 plus strain T minus 0.002 all over T times 250. Okay? Since yung nakuha nating strain T dito is here, copy natin. We have to paste here. Paste na natin dito. Your strain T, ito, is equal to 0.00134. This is less than or equal to 0.002. So, your P na gagamitin mo is 0.65. Okay? Mm. So, yan na. You have to use P as 0.65. Next, ang tinatanong, the last step, yung ultimate moment. Ultimate moment. So, how we're going to find the ultimate moment? May dalawang ways para makapaghanap tayo ng ultimate moment. So, at tayo dito ng text. Find the ultimate moment. Okay? Finding the ultimate moment or the VMN. Okay? Ultimate moment. Find the ultimate moment. So, MU is equal to VMN. Okay? Your MU here is equal to our fee here is ano yung fee natin dito? Kanina, ang fee natin is 0.65. 0.65 ang MN natin. Hanapin natin yung MN. Ano yung MN natin dito? Our MN here is equal to wait lang. Medyo naglumaktaw pala tayo. Sorry guys. After we get the fee here, hindi muna tayo magkuha ng ultimate moment. Ang gagawin pala natin is to find, wala pa tayong nominal capacity, wala pa rin tayong A and C. Wala pa tayong A and C pala dito. Sorry. Kasi kanina sa condition, yung beam natin is under reinforced. Yung A na, akabit natin sa A and sa C, yung ito, yung A and C na to ay hindi equal yung value ng A dyan, tsaka ng C. So we have to find the true value of A and C. So, okay? Ang gagawin natin, i-equate natin yung equation 2 sa equation 3. Then, ibabalik natin sa equation 1. Okay? Equate natin sila. So, AS, value ng FS, this is ES, strain S times ES, equal 0.85 FC prime. Your FC prime times yung A, value ng A natin dito is beta 1 times C times B. Okay? So, i-substitute na natin yung given, yung mga given sa variable na to. AS sa taas, meron tayong kanina, yung AS natin is equal to 3 times pi over 4. Okay, kaya natin. Pi over 4 times ang diameter na 25 squared. ES natin, ES, ano ba ang ES natin dito? ES natin is equal to ES. What is our ES here? 0.00 ito. ES is equal to ET. Okay? So ito. 0.0134. 0.00134 times yung loss of elasticity or yung ES is equal to 200,000. Okay? Times 200,000 times our 0.85 FC prime. FC prime, what is our FC prime here? Our FC prime is 21 megapascal. 21 times beta 1. Anong ginamit natin beta kanina is 0.85 times C. Wala pa tayong value ng C, which is unknown. Divide natin yung times C. Times yung B natin. Ang B natin sa problem is 205 dun sa cross section. 205. Yan. So we have to find the value of C. So we have 3 times pi over 4 times 25 squared times 0.00134 times 200,000 equal to 0.85 times 21 times 0.85 times C times 205. Shift solve. The value of C here is equal to 175. Oh, wait lang. Medyo mali ata yung natin. Strain S. Tama naman siya. 25, 00134. Double check natin. 200,000. 200,000. Ano kaya mali natin dito? 200,000. 0.85 FC prime. Your FC prime is 21. Beta 1 times C. Okay. C is missing. Your B is 205. Okay. Shift solve. Our C here is equal to 126.88636 millimeter. Yan, nawala natin yung C. 126.8636 millimeters. So, bakit iba lumalabas sa akin? 205. Let's say this is 358. Let's say 358. 205 talaga siya. Shift solve, this is 126. Ano kaya mali natin? Tama naman, 21, 85.85, C. Okay, proceed. We have to find our A. A is equal to beta 1, C. So our A here is 0.85 times the value ng C ng 126.88636. Our A times 0.85. A is 107.8534. 107.8534 millimeter. So, next, meron na tayong true value ng A and C. We have to compute the nominal moment capacity or yung MN. Okay? So, we have to compute our nominal capacity, nominal moment capacity. AS Fy D minus A AS Fs D minus A over 2. So, we have to compute our pang number na tayo, pang number 6. Okay, ang haba ng computation natin. Okay, number 6, compute the nominal moment capacity, or let's say this is Mn. Okay, your Mn denote as Mn is equal to AS Fs times D minus A over 2. Okay? Your is equal to Fs is equal to yung kanina, our equation here. Nasaan na yan? Here. ES, strain S times ES. Strain S times ES, which is equal to 0.003 times our effective depth. Effective depth is 283.5 minus the new value of C, which is 107.85. So let's copy the value of C. Copy value of C, 107.85.34 all over 285, 283.5. Ay, this is mali pala. This is 107. Kasi our formula for strain S is 0.003 times effective depth minus C all over C. So this is copy, go to base, times yung ES na 200,000 equal to, okay, 1003 times effective depth 283.5 minus 107.8534 over 107.8534 times 200,000. Okay, this is 977.1408 MPa. That's our Fs pala. So we have to okay, paano ba ito? Okay, copy natin to. Ba't ayaw makopy? Okay. Paano ba natin makopy to? Last tool. Yan, copy natin tong formula. Paste natin. Ay, dito. Paste here. May value na tayo na Fs. So, ES is equal to 3 pi over 4 Fs na 977.1408 minus effective depth 283.5. Value ng A. Ano ba ang value ng A natin? Ay, mali pala. C pala yung nakopy natin. So we have to ibahin natin to. This is ang C natin is 126. So we have to change this one also. Okay. Our value here is maiiba. So this is 126. 126.88636. 126.88636. Your Fs here is 740. 740.5696. 5696 MPa. So times Fs 25 squared times your Fs, which is equal to 740.5696. 5696 times your effective depth na 283.5 minus your A. Your A is, bain natin is 107. So that's 107. Okay. Okay, times, this all over 2. Half none. So your Mn is equal to, okay, answer times 3 times pi over 4, okay, times 25 squared times 283.5 minus 107.838534 divided by 2. Your answer will be, so malaki siya in terms of kilonewton lang natin. So 250, your nominal moment capacity is 250.37 kilonewton meter. Okay? So, after nyan, yung reduction factor natin kanina, meron ba tayong reduction factor? Yun. According to code, we have to copy this one. Okay? According to code, yan, getting our reduction factor. So, if your strain T is less than or equal to 0.002, you will use reduction factor of 0.65. If your strain T is greater than or equal to 0.005, you will use 0.90. Since our strain T is less than or equal to 0.032, we will use 0.65 as our reduction factor. So, we have to find or get the ultimate moment capacity. Okay? Compute our ultimate moment capacity, or the MU. Okay, we have already had a value of nominal moment capacity. Our MN, isulat ko lang. Our MN here is equal to 250.37 kN per meter. So your MU is equal to VMN. MU is equal to 0.65. Nominal moment capacity is 250.37. Your ultimate 250.37 times 0.65, we will get 162.7405. This is the ultimate moment capacity. Okay. Okay. That's the final answer. Haba na solution. Okay. This is our final answer.